see if you want to picture any other angle from 11 to 22.
Can we do 3 pi over 4?
Yes, let's do 3 pi over 4. Maybe we should also look at a negative one. So let's do 3 pi over 4 and maybe also negative 120 degrees. Very good. 3 pi over 4 and negative 120. Okay, perfect. Okay, so when we look at 3 pi over 4, I see pi over 4. When I see pi over 4, I know that this is 45 degrees, and I have 3 of 45. Very simple. How come? 2 of 45 are here, and I need one more. That's the easiest possible way to look at it. So this is, of course, 90 plus 45, 135 degrees, or 3 pi over 4. Pi over 4 is the easiest angle of all because it's right in the middle. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and you can continue. Because there are 2 pi over 4 in each quadrant. 45 plus 45 is 90. 45 plus 45, another 90, and so on and so forth. So 3 pi over 4, very easy. What about 7 pi over 4? Very easy. 1, 2, 3, 4, 5, 6, 7. Done. This is 7 pi over 4. Please remember, pi over 4 is a friendly angle. When it comes to 60, it's more difficult to count. 30 is not difficult, but 45 is the easiest. 1, 2, 3, 4, 5, 6, 7. What about 11 pi over 4? Very easy. There are 8, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I want 11 pi over 4. So that's a nice one. Any questions on this? Let's look at a negative angle this time. Negative 120. Okay. We start here. We have to go this way now. So this is 90. I need 30 more. 30, 30, 30, 30. There are 3 of 30 in each quadrant. So this is 90 plus 30 more. This is it. This is negative 120 degrees. Or 2 of pi over 3. 2 of 60. Negative 2 pi over 3. Because this is 60. So remember, pi over 3 is the biggest. Pi over 4, friendly. Pi over 6, the smallest. 30, 45, 60. Are we okay with picturing angles? As you see, the initial side is on the x-axis, and the terminal side is in the third quadrant, and it's a negative angle. Here, for 3 pi over 4, initial side, of course, it's a positive angle. The terminal side is in the second quadrant. My 7 pi over 4, initial side, terminal side, and it's in the fourth quadrant. Never be afraid of pi over 4. Very friendly, easy to count. Never be afraid of pi over 3. 30, 30, 30, 30, 30, 30. 3 of 30 in each. The 60 is a little bit more cumbersome because it doesn't fit in any quadrant. I mean, it's right here, and then it's here, and then it's here, and then so on and so forth, all over the place. So 60 requires care. But 30 and 45, nice. Are we okay with picturing angles? Can we move on to changing degrees into radians and radians into degrees?
Yes.
Okay. So I have one on the handout, and then I'll let you choose others. So I think I'm on page 5. Am I on page 5? Yes. Okay, so 330 degrees. So we want to change 330 degrees into radians. All I have to do is write 330 And remember 1 degree. I don't remember. Okay, I will write it on the side. Pi equals 180. If I want 1 degree, I have to divide by 180. You don't have to remember. It will become second nature soon. But you don't have to remember it, right? You can write this. If you want 1 degree, you divide by this. If you want 1 radian, you divide by this. So all I have to do is write multiplied by pi over 180. And yes, I have to simplify as much as possible. Do not leave it like this. It has to be fully simplified. How do I do that? Okay. So I have 33 pi over 18. I have to simplify by 3, and I get 11 pi divided by 6. This is it. Is it difficult to picture this? No. Why not? 11 pi over 6. 3 more, 6, 3 more, 9, 10, 11. It's 11, 3 are here, 3 are here, 3 are here. This is 9. I need 2 more. I need a 30 and another 30. This is my angle of 330 if I want to picture that. We were not asked to do that, but I wanted to make sure you understand how to do it. 11 of 30. 3, 3, 3, and 2 more of 30. Once you understand this, you will never forget how to count these angles or calculate any of this. Okay, so now we are ready to share our screen again, my screen again. So we can move on now. Let's change anything you want. Convert each angle in degrees, that is in degrees into radians, and vice versa. Choose anything else you like. You'll see how easy this is. Anyone? No one would like to pick anything? Is anyone with me? I've been abandoned.
Can we do number 44?
Number 44, thank you. Negative 225. Good pick. So we want to change it into radians. Very good. Negative 225 degrees. Same method. I already have it here. I say this times pi over 180. I cannot leave it till I completely simplify this fraction. So negative 225 pi divided by 180. I have to simplify by 5 because they both end in 5 or 0. So when I divide 180 by 5, I get 3 and 6, I think. Correct me if I'm wrong. And if I divide this by 5, I get 45. And they don't have any other common factors. This is it. That's all you needed to do. Any questions? Oh, actually, no, we have to simplify by 3. Just realize 45 and 36, they both have a common factor of 3. So this is 12, and this is 15 pi. Oh, look at that. And another 3. So negative 5 pi over 4. I didn't take my own advice. I have to fully simplify. And now this is fully simplified. Always simplify fully. 45 and 36, actually, I could have simplified by 9 already. Good. Anything else? Before we move on to 2 formulas, the arc length and the area of a circular sector. Do we need to work on anything else? Do we need to convert any radians into degrees? That's easy, right? Because you already know that pi over 6 is 30. You already know that pi over 4 is 45. This one is more difficult. This one is more difficult. Not really. You only have to replace pi by 180. So let's choose. Let's choose one from here and then move on.
Can we do 54?
Yes, 54. So what number was that? The negative. Okay, this is 44. Okay, so we have a 5 pi over 12. So for 5 pi over 12, oops. All you have to do, because you don't know what pi over 12 is, all you have to do is just replace pi by 180. That's the easiest thing to do. So we have 5 multiplied by 180 divided by 12. I'll simplify by 6. I'll simplify by 2. So 5 times 15, and that's 75 degrees. Any questions? Any questions? Okay, so let's look at arc length and area of a circular sector. I think I'm on page 6. I am. Arc length, area of a circular.
Could you go back to that last page for a second?
Of course, anytime. Here it is. Is that okay?
Yeah, thank you.
Thank you. Good. Moving on. Okay. So the arc length. We have a central angle. So it's called central angle. In other words, the vertex is at the center of the circle. And of course, we have the initial side and the terminal side. I'm going to call this angle theta. I'm going to call the radius r. And this is the arc length. We like to call it s, lowercase s. So, very important to remember, theta must be in radians, not in degree. The formula does not work if you have 30 degrees and you put it in the formula. It's not going to happen. So S equals R times theta, but theta must be in radians. We're going to look at that different situations, and we're going to work on problems in a moment. I want to talk about the area of a circular sector. Why is this important? This is very important when you get to Calc 2. Okay, I don't want to skip this. Okay, so let's take a look. Again, I have a central angle. Again, the angle is theta. I do have the radius. And this piece is what it's called the circular sector. Everything, this sector. And we want to determine this area, that piece. The formula is 1/2 r squared theta. Again, theta has to be in radians. So now I would like us to work on different examples with these two formulas. Any questions? Any questions for me, please? Okay. So we have a few examples on the handout, and then separately I chose a few examples with the formula for the area of the circular sector. So I can bring up the handout. You can choose from the handout, or we can just go directly to the book. It's up to you. Here it is. So here's the handout. It says you're given R, theta, find S. You're given theta, S, find R. You're given R, S, find theta. You're given R, theta, find S. So let's choose. What would we like to start with? Which one, please?
74.
Okay, so let's start with 74. 74, perfect. Oop. So theta equals 1/4. There is no need to write radians. They wanted to specify. But once we say theta equals 1/4, we know it cannot be degrees because the little bubble for degrees is not there. S equals 6 centimeters. And they want us to find the radius. Perfect. All I have to do is write this little formula. So S equals R times theta. Have to make sure that the angle is in radians, which it is. Okay, so this is 1/4. I am asked to find the radius, which I don't have. So R times 1/4. But I am given S as being 6. The simplest linear equation. How much is R? What do I need to do to get R? Anyone, please? I know everyone knows how to solve this equation for R. I have no doubt.
Would you multiply by 4?
Exactly, it's cross multiply. So this is 24 centimeters. Perfect. Any questions? Okay, let's see if we want to choose anything else. Anything. Do we want to choose anything else?
Can we